Probably the simplest and easiest type of problems that can be solved using triangles are problems where you're asked to solve for the crosswind component. So you're given some winds and you're asked what component or what the crosswind component of that wind actually is. So here in this example, we're told that we have a surface wind from 180 at 25 knots, and we're going to land on runway 13. We're asked to figure out what the crosswind component of that situation is. So first let's draw it out. So we're coming in to land on runway 13, and we have a wind that's kind of cutting across the runway here at 25 knots straight out of the south. We know that our magnetic heading is 130 because we're landing on runway 13, and we know that the magnetic wind direction is 180 because it's a surface wind. So we start by overlaying our triangle onto our little diagram here. So we notice that the right angle occurs basically on the runway, and the angle that we're interested in is the difference between our heading and the direction of the wind. The value that we're solving for is x, which is the crosswind. So if we take 180 and subtract 130, we get 50, or 50 degrees. So that's the value of the angle that I've labeled. And now we have a right triangle that we can solve using a trig function. Since in this case, we're given the value of the angle, and we're given the value of the hypotenuse, and we're solving for x, which is the side opposite of the 50 degrees, then we want to use the sine function. Plugging in our values, 50 degrees for the angle, 25 knots for the hypotenuse, and x for the crosswind, or the opposite side, and then solving for x, we get 19.2 knots. When we go back to our problem, we look and we see that 19 knots is a choice, and it turns out it's the correct one. So in solving these problems, you can always compute the crosswind component by just taking your wind speed and multiplying it by the sine of the difference between your wind direction and the runway heading. But it's probably easier to just visualize and draw out the triangle because then you don't have to memorize anything. If you were doing it using a chart or using the crosswind component chart from the book, how you would solve this problem is by first tracing along the angle that corresponds to the difference between the wind direction and the runway direction, which is the same angle that we're plugging into our sine, remember? So in order to solve this problem, you still have to, even if you use the chart, you still have to figure out the value of that angle. Once you figure out the value of that angle, you trace along that line and then go down and see where it intersects the x-axis, or the bottom axis. And you get your value from there, 19 knots. So how does this chart work? Let's see what's really going on here. Well, all this chart does is it allows, by following the directions, you're drawing the triangle that we overlaid onto our runway. So look, there's your triangle. The hypotenuse was the wind strength. Remember, the first step of this problem is to trace along the hypotenuse basically up until your wind value. The bottom side is your crosswind component, and the side over here on the right is your headwind component. So all this chart really does is just provide a way to compute sines and cosines by reading them off of a chart.